Hello everyone, welcome to today's class. In this lecture we are going to discuss about inverse functions, and before even starting inverse functions we have to understand composite functions. Okay. So let's first of all get a brief idea what this is, how it is working. So let's say you have a function fx. Okay. So you put the values of x as x1, x2, x3 inside this. Okay. And what do you get? You get some value as fx1, fx2, fx3. Okay. If you put this inside, see these are some values now. If you put this inside another function, let's say that function is g of x. Okay. So what do you get? You get, let's say this value was 1 na? Or let's say 3. Okay, let's say this is 3. So what do you get? You get g of 3. And what is 3 actually? fx1 na? So basically you get g of f of x1. Okay. Similarly, this you get g of f of x2. This you get g of f of x3. Okay. So once you get a value from some function, you put it inside another function. That result is called your composite function, and this is what g of f of x is. It's also called gof x. Okay. This is how it is working. We can do the reverse also. Sorry, this is not gof, this is fog. One sec. We are putting, so yeah, this is gof. I've written it correct. Okay, g of f of x. Okay, so you are putting g of f of x means you are putting the value of fx in gx. That's the meaning of gof. Similarly, you can get fog also. F of g of x. So you put the value of gx in fx. Okay. So instead of starting with fx function, you start with gx function. Okay. Whatever value you get, you put inside the f of function. Okay. All right. So this is some basic understanding for composite functions. Now let's look at some questions. How to generate those functions. Okay. You should be comfortable while generating fog and gof. Also get comfortable with this notation g of f, f of g. You can have f of f also, fof, gog, like that. Okay. Let's see some functions. fx is let's say x square, and your gx is cos x. Okay. You have to find fog and gof. Okay. All right. So f of g of x, first of all, let's write from the basic. Fog x or fog x is equal to f of g of x means, first of all, you put the value of g of x. Start from the inside. So this becomes g of x is cos x. Okay, so f of cos x. Now what is meaning of f of x? If you put x inside it, it becomes square of it. So so if we put cos x inside this, it becomes square of it. Okay, the first function fx is doing square of it, so this becomes cos square x. Okay. Next, if we do gof x, that is g of f of x. So g of, what is f of x? X square. Now what you are going to do, what is your gx? Cos x, means if x is put inside, it becomes cos of it. If x square is put inside it, it becomes cos x square. Okay. So you might think that still it is generating, the students can think like it can still generate cos square x, but to avoid the confusion, what I'll say is you replace every x with x square. If you want to find g of x square, so in order to avoid any confusion, what do? you replace every x with x square. If you are replacing this x with x square, replace this x also as x square. So this becomes cos x square. This is different. This is cos of x square, not cos square x. Okay. So while getting the g of x square, remember that you replace each x with x square. Okay. Let's take few more examples. It will clarify your fog and Goff. And let's take fx is equal to mod x and gx as your sin x. Okay, let's find fog and Goff. So fog x is f of g of x. Start from inside. What is g of x? Sin x. So f of sin x. Now in order to find f of sin x, what do? Replace every x with sin x. Okay, so f of sin x, it will become inside mod, this x is present, replace this x with sin x, so mod will be as it is and inside it will come sin x. Okay, so what we have done, replace x with mod x. Similarly, calculate Goff. So g of f of x, that means solve the inside one, g of mod x. Now what do? Now you replace every x inside this gx function with mod x. Every x. So this will also become mod x. This will also become mod x. So what is this? This is sin mod x. Those two are different things. Okay. The result of this can come negative as well as positive. The result of this will always be positive because mod is present outside. Okay. All right. Next, let's look at this fx is e raised to power x, and gx is log base ex. Okay. So now fog. Now fog x is f of g of x. That means f of g of x is log x, log base ex. Now what do? In fx, replace every x with log x. So if I replace e raised to power x with log x, so it becomes e raised to power log base ex. Sorry. And you know, we have done this a lot. These two cancels, e raised to power log always cancel. So it becomes what? X only. Okay. Similarly, Goff x, that's g of f of x. Now that means g of, what is f of x? E raised to power x. It becomes, now what do? You replace every x in g of x with only x. Replace every x with e raised to power x. So that becomes one second. E raised to, log base e. X was replaced with e raised to power x. So e raised to power x. Now you know that this power in can come down. That's the property of log. So that becomes x log base e. What is log e? 1. So that it becomes x again. All right. One more example. Let's complicate things. Fx, slightly we can complicate. Fx is x square plus 2. Gx is 1 minus 1 upon 1 plus x minus x. Okay. Fog x, that is f of g of x. So that is f of g of x is 1 minus 1 upon 1, 1 minus 1 upon 1 minus x. Quite complicated, But that's the idea. Replace every x with this quantity, this figure. So if I replace x with 1 minus 1 upon 1 minus x, so it will become 1 minus 1 upon 1 minus x whole square plus 2. We can solve this further, but that's the idea. At least you should get this expression correct. Okay. What you can do is take LCM maybe. 1 minus x, this becomes 1 minus x minus 1 whole square plus 2. So it becomes fog, na? We are calculating x square plus 2, na? So whole square. Ninth, we have done 1 minus x minus 1. So 1 cancels, no option. This becomes minus x square minus x upon 1 minus x whole square plus 2. So we get minus x square 1 minus x whole square plus 2. If you want to take the LCM, still you can go for this. Okay. This will become plus actually. Now you can take LCM. 1 minus x whole square plus 2 bracket 1 minus x whole square, and further solve that. X square plus 2 times x square plus 1 minus 2x upon 1 minus x whole square. This becomes 3x square minus 4x plus 2 upon 1 minus x whole square. Anyways, we can solve it as per the requirement, but that's the idea. Okay. If only you get this step correct, you can further solve it down as per your choice. Let's calculate g of f of x. I'll calculate here only. G of f of x. That's g bracket f of x. That's g bracket. What is f of x? X square plus 2. So I'm going to replace this x with this one. That means this x will also be replaced. So that will become 1 minus 1 upon 1 minus, and this is x square plus 2. Replacing x with x square plus 2. So now 1 minus, this becomes minus 2 minus 1 minus x square. You can take the negative out. It becomes 1 plus 1 upon 1 plus x square. So it becomes x square plus 2 upon x square plus 1. Okay. So I hope after solving these many questions, you should be now comfortable with the calculating fog of. Okay. So one last variation. It might confuse you again. The task is to cover all the possibilities as much as possible. Fx is some constant, c. Gx is sine x square. Okay. So let's calculate fog. Okay. So fog will be f of g of x. That is f of sine x square. Okay. Now if you look here, you'll replace this x with sine x square, but there is no x present here. Why? Because it's a constant function, means it is independent of whatever value you put for x. Whether you put x as 1, 2, 3, 5 or anything, even you put sine x square, it will remain constant. That means here it will still be c, because there is no x here to replace it with anything else. We want to replace it with sine x square, but there is no x present, so it will be same. So fog x is same as your fx. Okay, interesting. Now let's try g of x. That is g of f of x. So that is g of, what is f of x? C. So now it's possible to replace x with c. So this x will be here replaced with c. I'll change the color for highlighting. This x needs to be replaced with c, so I'll replace this x with also c. So this is sine c square. That's the answer. All right. Fog off, done. Let's understand this now from roster point of view also. Although it's very easy as such. So there is some function f is given between these two sets. So these are sets, they are not defined in which means they are in which order they are related, it's not defined here. Similarly, your gx is defined on these sets, they are being defined on these conditions. Okay, so basically if you put, I'll draw this with the help of diagram and I'll solve it with the normal way. F, okay, for let's take, you have to calculate GOF na, so first fx will come, so x, then fx, then gx. Let's see. All right, so the values are, x values are, this is 2, 3, 4, 5. Okay, 2, 3, 4, 5. Okay, these are the values of x. Then that generates some f of x. That f of 2 is 3, means 2 is being put inside the function and it generates 3. 3 generates 4. 4 and 5 both generate 5. Okay, so although it was looking like you are adding 1, but 4 you got 5, 5 also you got 5. Okay, now it is saying that if you put 3 inside g of x, if I put this value inside g of x, g of 3 is 7, g of 4, if I put this value inside your gx, it generates also 7. Okay, so both same values. And g of 5 and g of 9 is 11. G of 5 is 11, but g of 9, I don't think we will be able to generate g of 9, because yes, if I put the value of 9 inside then this gx, then only it can be generated, but we are getting GOF, so only the values of f of x we got will be put inside g na. So only this values will get, that generates your basically g of f of x. All right, this is done. This is GOF x. Okay, basically this is what we have done through the help of diagram. Okay, this is our GOF x, so I'll say g of f of x, g of f of 2 is 7, and g of f of 3 gets to 4, 4 gets to again 7, then g of f of 4 gets to the value of also 7, and g of f of 5 gets us to 11. Okay, from diagram it is there. Now let's understand it from direct. If you want to calculate, suppose the exam in the exam you asked only g of f of 2, so what do you, how do you solve this? You solve it like this: g of f of 2, GOF 2 means g of f of 2. Okay, what is f of 2? F of 2 is 3, so calculate, replace f of 2 with 3, that's 3. Okay, And what is g of 3 as per the question? G of 3 is 7, like this. Okay, similarly g of f of 3 also. So what is f of 3? F of 3 is 4, so that means you have to calculate g of 4. What is g of 4? That's also 7. So this way you can calculate directly. Okay, so g of f of 4, what's f of 4? 5. So g of 5, what's g of 5? 11. And lastly g of f of 5 we have to calculate. So what is f of 5? F of 5 is also 5, so that's g of 5. G of 5 is 11. So either you can calculate like this, or you can understand from the help of diagram also. It's just that you can now actually see things happening here. Okay. So whatever values of x, fx we got, we put it inside g to get the value of g of f of x. Okay. Sorry, g of f of 4 was 5. F of 4 was 5, and 5, g of 5 was 11, no? So I have written here g of f of 4. F of 4 got to 5, 5 got to 11, so this should have been 11. Okay. All right. Okay. So far, this pretty much helps you to understand what is GOF, what is fog. All right. Now let's talk about inverse functions. I think we have done a lot for GOF and fog. So this is a basic definition. The definition is kind of weird. I'll explain you how it is done actually. But first of all, let's understand what is an inverse function. Then we'll talk about this. Okay. Let's say you have some values of x. Okay, you put it inside a function and you got fx. Okay. Let's say you got x as 2 and f of x is, let's say, 5. Something is happening. Okay, this is happening because of the function f. Okay, now I want to do the reverse. Now I want to put 5 as a value in some function so that it generates me the original value of x. So that is your inverse function, f inverse. Okay, means what is inverse going to do? Right now it is doing f of 2 is 5 na? So what will it do? So f inverse of 5, it will give me the value 2. Means whatever was the value of y you were getting, you get now x for it. Okay, y is f of x, na? Like this. So usually we put the values of x, we get the value of y. Inverse function, what does it do? We put the value of y and get the values of x. Okay, that's what inverse function do. Okay, how do we know that inverse of a function will exist or not first? Okay, so inverse exists with this condition, that inverse function, a function is invertible. Invertible means its inverse exists if GOF x and fog x are identity function of x and y. This I is identity function. Okay, means somehow if we solve GOF x and it got x, value of identity function of x is x itself, means you solved it and you get the value only x, or you solved f of g of y. Okay, and it becomes identity function of y. If that happens, we'll call this as inverse functions of f. Okay, one question we were solving, log 1. Yeah, see this, e raised to power x, gx is log x. If we put this, we got fog x as x. Okay, now this is the identity function, so we can say that log and exponential, they are inverse function. Though I have already told you that if we take log on the other side, it becomes inverse. It becomes anti-log. Anti-log is basically e. Okay, so basically log and e are inverse function. Now it justifies it. Okay, so far you were accepting it. Now there is a justification why they are inverse function of each other. Why log and e can cancel each other. This is why it cancels. All right. A simple way to say, yes, this is another definition, okay, but a simple way to say, if a function is 1 1 and onto, then it is invertible. Okay. If a function is 1 1 and onto, we can say it's invertible. So we don't have to do anything about this. I'll teach you about this definition with the help of a question itself. Let's see a question. Again, the kind of proof as such will not be asked in MCQs, but you should have the understanding how things are working here. So first of all, we have to show that it is an inverse function and then find inverse of this function. If I have to simply say this f of x, we'll call this as y is f of x is equal to x plus 4x plus 3. Now y is equal to 4x plus 3, that's your function. If you want to generate inverse function, what do? You find x. So I can say x is equal to y minus 3 upon 4. Now this is in terms of y, so that's why we say this is some g of y. Okay, and somehow this is also the inverse function of f. This is f inverse. Since it is written in terms of y, so it is f inverse y. If you want to write this as f inverse x, just replace y with x. Okay, this is just a notation here. We focus on f and g. Whether it is g of x or whether it is g of y, doesn't matter. Okay, but we will be solving this right now like this. We'll call fx as y and we'll solve the value of x. We'll get in terms of y. That will be your inverse function. But in order to prove it is invertible, what we have to prove? We have to prove it is 1 1 and onto. And I told you, you can check this directly also, or there is a proper mathematical proof. How do we check a function is 1 1 or onto not? So to check fx is 1 1, there was one definition, fx1 is equal to fx2. If it generates x1 equal to x2, it's 1 1. So 4x1 plus 3 is equal to 4x2 plus 3. 3 cancels, then 4 also cancels, x1 equal to x2, yes, 1 1. Okay, therefore 1 1. Okay, and in order to check the onto part was checked by calculating Fogg and Goff effectively. Now we used to replace the value of x in your f of this f of y, f of x, I mean. So to get we have to go for the definition, we have to calculate Goff x. So g of f of x, we already have g of f of y, g of y. Now g of f of x we have to calculate, that is g of f of x like this. What's f of x? That's 4x plus 3. Okay, we put this inside g. This is our g function. Okay, right now this is the g of x, g of y, I will say. So replace each y with 4x plus 3. That means this y will be replaced by 4x plus 3. Let's say 4x plus 3 minus 3 upon 4. 3 cancels, 4x by 4 cancels. You can see Goff x is only become x. This is called identity function in x. And now I can say, yes, as per the definition, its inverse exists. Okay, this is the definition. If exist is such that Goff is identity function of x and Fogg is identity function of y. I'll check the Fogg also. We have to check Fogg function. Fogg, f of g of, since it is in terms of y, so I'll write g of y. Let's calculate f of g of y. I'll solve it here, otherwise it will be confusing to you. Fog I'm solving separately here. Fog y. So f of g of y. So what was g of y? Y minus 3 upon 4. Okay. So y minus 3 upon 4. Okay. Now you replace each x in fx. What was the fx? This one. So you replace each x in fx with y minus 3 upon 4. So I'm going to show it here. 4 into y minus 3 upon 4 plus 3. 4 cancels. This is y minus 3 plus 3. It also cancels. It becomes y. So it becomes an identity function in y. That's the conventional way to get a function is invertible or not. Gof x will become identity function of x. Fog y will become identity function of y. Okay. What is this g? G, we will generate this by calculating the value of this y. Calculating the value of this x. Okay, we'll generate that. Okay. Fx will be given to you. You generate g of y. How do you generate? You get the value of x in terms of y. That is your g of y. And interestingly, that's your inverse function also. Okay. So we indirectly calculated the inverse first, and then we checked whether yes, that was the inverse or not using this Goff and Fogg. Okay. Let's do one more to get more clarification. Let's solve this. This will be interesting. All right. Nice. You have a question in terms of sets. F is defined from these two sets, G is defined from these two sets. They are being related with this, that f of 1 is A, f of 2 is B, this is C. So I'll relate it like this: 1, 2, 3, A, B, C. Okay, 1 is this, that's f function, and then A, B, C, they are being related with apple ball. A is related with apple, B is for ball, C is for related with cat. Okay, that's G function. Okay, he is saying show that f and G or G of f are invertible. Again, showing is the conventional part. Let's find f inverse, G inverse, and Goff inverse. Okay, and then one interesting property comes out, that Goff inverse is f inverse of G inverse of f inverse of G inverse. Okay. All right. Now f inverse will be like this. Now f inverse A will be, you have to go for the reverse now. F of 1 was this. Now you use the definition itself. F of A, f of 1 was A. It implies f inverse A. Take f on the other side, it becomes inverse function now, is equal to 1. Similarly, f of 2 is B. That implies f inverse B is 2. F of 3 is C. It implies f inverse C is 3. Okay. Similarly, you calculate your G. G of A is apple. That implies G inverse of apple is equal to A. So now I'm writing directly G inverse of ball is B, G inverse of cat is C. Okay, like this. Now we have already calculated the inverse of everything. Now he is asking us to calculate Goff inverse. So we have to calculate G of f of that and inverse of it. Okay. So should we do directly? Goff inverse directly we can calculate now. Goff inverse G of f of, you have to do the reverse of this function. This is what we are calculating. This is we are calculating fog, na? So if we do the reverse, it will be Goff inverse. Okay. So let's calculate something else and then I'll show you directly. Let's calculate f inverse of G inverse of apple. That is f inverse of G inverse of apple is A and f inverse of this is 1. Similarly, f inverse of is O, na? Basically G inverse ball. So G inverse ball is B. So f inverse B is 2. Okay. Similarly, f inverse G inverse cat, this is f inverse of C, that's 3. Okay. Isn't this your Goff inverse? This was Goff, na? What is this? I'll say that G of f of 1 is apple, G of f of 2 is cat ball, okay. G of f of 3 is cat. Okay, from this we can interpret this, and you can clearly see if I generate Goff inverse of apple. Okay, Goff inverse of apple is 1, of ball is 2, of cat is 3. Okay, of course you can directly relate this, but we have shown this also, that f inverse of G inverse of the function, the values are also like 1, 2, 3. So basically I can say Goff inverse is f inverse of G inverse of x or Goff. So remember this as a property, that for inverse, it's kind of like matrices, like AB inverse was B inverse A inverse. Now, so for function also, if you are calculating inverse of a composite function, it becomes inverse function of f and then inverse function of G. The order changes. That's the key aspect that you have to take from this example. Okay, I mean in the exam you are not getting these kinds of simple, that 1, 2, 3 apple ball cat, but this is to make you understand that how inverse is written effectively, what is f inverse of G inverse of something, and what is this Goff directly, and how we are calculating the inverse again from it. Okay, now the kind of questions that are usually presenting themselves in the exam are like this. Whether something you have to check whether the inverse function exists or not. Okay. So they will give you some conditions and you have to check if the inverse function is defined or not, and if it exists you have to find them. Okay. So 1, 1 means for a example, 1, 1 means 1 is being generating 1, 2 generates 2, 3 generates 3. 1 value of x is getting you 1 value of y, unique value also. So clearly it's 1, 1. Now go back to the basic definition of 1, 1. 1 value of x will get 1 unique value of y. So 1, 1. Okay. And every y has some x. Yes. So on to. Therefore f inverse exists. and f inverse will be, in order to write inverse in the roster form, what do? You reverse the orders of the values. Although even if you reverse these, they'll still remain the same. F inverse will also be 1 1 2 2 3 3. Okay, basically you write this in order. 1 comma 1 is like this, you write the reverse, 1 comma this 1 1. Slightly weird because the values were given like this. I'll explain if something else also comes as a inverse. Okay, B is again 1 2 3. Sets are defined like 1 2 3 na. 1 is again related with 1, 2 is also relating with 1, 3 is also relating with 1. This is clearly many 1, not 1 1, and this is not on 2. If this is not many 1, not on 2, definitely therefore not invertible, or f inverse does not exist. Last 1 2 3 1 2 3, 1 has 3 as the value, 3 has 2 as the value, 2 has 1 as the value. So every element, every value of x has a unique y. Okay, so yes, 1 1, and all y are related with some x, so yes, on 2. Okay, so if it is 1 1 and on 2, so f inverse exists, it's invertible, and f inverse will be, I told you that reverse the order. It is 1 comma 3 na, basically the first. Now you write reverse, 3 comma 1, then 2 comma 3, and lastly 1 comma 2. Okay, all you have to do is write down the elements in the reverse order. 1 comma 3 will become 3 comma 1, 3 comma 2 becomes 2 comma 3, 2 comma 1 becomes 1 comma 2. Okay, all right. Fog we have calculated, Goff we have calculated. Let's do this example. All right, invertible. Last question. So MCQ form questions. This is the function. He's asking for f of x. Okay, so this kind of question can also be done like the same idea. F of x, write like this. Replace fx first of all. Fx is 3 minus x cube. This itself has a power of 1 by 3. Now what you have to do is replace this x with this value. Means this x here will be replaced with this complicated value. Be very careful with it. This will be 3 minus x will be replaced by this 3 minus x cube power 1 by 3, and there is a cube present on top of it, so cube of it, and then bracket, and then again power 1 by 3. Again I'll repeat. What I've done is replace this x with this value. Okay, that becomes f of 3 minus x cube power 1 by 3. Okay. Now let's solve this. We can combine these two powers. Okay, so it is 3 minus, this becomes minus, they cancel each other, no? 1 by 3 3. So this becomes 3 minus x cube only, so minus 3 plus x cube power 1 by 3, 3 also cancels. This is x cube power 1 by 3. What is that? X. Okay. Interestingly, see, f of x is coming 1, the x, na? This is like identity function. We can say that f is the inverse function of this. Usually like Goff and Fogg should be there, no? So this time only f of x is generating the identity function. So f itself is the inverse function of itself. So f is inverse of f is inverse function of itself, or I can say f inverse is equal to f. So another question can be formulated, calculate f inverse of this. So inverse function will also be the same one, the same function as it is. Okay, it's saying again some relation is there, a function is there. This is defining the domain and the range, okay, of this, that from which set to which set we are relating them. So domain clearly should not have x as minus 4 by 3, otherwise denominator becomes 0. So this part startingly is only making this function defined. So focus only on the function. This is f of x, he is saying inverse of it. Now I told you, in order to find inverse, what you have to do? You replace this by f of x by y and calculate x. Y is equal to 4x upon 3x plus 4. Calculate the value of x. Multiply this, 3xy plus 4y is equal to 4x. We want single x, so combine the x together. 4y equal to 4x minus 3xy. Take x common, 4 minus 3y. So it becomes 4y upon 4 minus 3y is equal to x. Or it is also called, I told you this is a function of y, so it can be called g of y. Okay. So which option? 4y upon 4 minus 3y. This one. Okay. This one is the correct one. All right. One additional topic as such, see, we have done one function and onto functions. Sometimes the questions are regarding number of functions. Okay, I'm not talking about just number of functions. He can ask you number about one function, onto function, one and onto function. I'll present it in the form of a question, so you'll have a better understanding. The question asks us, set A contains 5 elements and set B contain 6 elements. Number of 1 and onto. Okay, both 1 and onto mapping from A to B is, okay, this is what you have to find. So in order to find number of 1 and onto function from A to B. So A will have m elements, B will have n elements. Okay, I'm assuming that. So in that scenario, okay, 1 and onto, so it will have answer as n factorial. Is asking for number of 1 and onto, na? Okay, yes, n factorial. Only if m is equal to n, means number of elements of A and B should be equal, otherwise the answer is 0. Okay. So since A has 5 elements, B has 6 elements, so M is not equal to N, therefore answer is 0. So remember this condition. Okay. Next question. A set A, again same scenario, set A contain 7 elements and set B contains 10 elements. He's asking for number of 1 functions. You can say number of 1 functions, number of 1 mapping, okay, from A to B. From A to B. So number of 1 function, only 1, there is no condition on to, okay, from A to B. A has M elements, B has N elements, okay, is equal to NCM into M factorial if N is greater than equal to M, and 0 if N is less than M. Clearly, if your number of elements in this set, A set, is more, you will not have any 1 function. If you don't have 1 function, 1 onto will also be 0. You can see that from earlier scenario also. So for this, the answer will be, see, answer is direct as long as you have this information. Okay. And these results are nothing but they are being generated for the help of PNC and these definitions that we have studied. Okay, so take this as a direct formula. NCM, no? So N is 10 C7 into 7 factorial. Okay. All right. And as such, we know total number of functions are 2 raised to power mn. Okay. One second. I'll give you the number of total functions from A to B. Okay. A has M elements, B has N elements, is equal to 2 raised to, sorry, not 2 raised to power, N raised to power M. Okay. Suppose they ask you this, so this is additional information. Number of total function. All right, I think that's it. That's all for your inverse functions. 1 and onto, fog and Goff we have already covered now. Okay, that's it. That's it for this class. See you in the next lecture. Good day, everyone. Bye.